In this video, we are going to look at some questions from section A of Mathematics paper 2 for 2017. This was written by the external. Now let's look at the first question, given that matrix K. So we have this matrix here. Then our first question is we want to find the determinant of this matrix. So the first step is first we need to identify the elements from the major diagonal. So the one in green is our major diagonal. Then also we need to have this diagonal one. This one is minor diagonal. So after we are done, now we can write the formula. So determinant is equal to, we need to find a product from the major diagonal. So this number 10 multiplied by negative 2. Then minus this 11 times negative 2. So the determinant of matrix K is equal to 10 times 2 is negative 20. Then here we know that this negative times this negative will give us positive. Then 11 times 2 is 22. Therefore, our final answer is positive 2, since the bigger number has a sign of positive. Now let's move on to finding the inverse of K. So inverse is equal to 1 over determinant multiplied by adjoint. So we need to find the adjoint. So let's find the adjoint of matrix K. So for the adjoint, you need to swap the elements from the major diagonal. Then so this negative 2 will go here, then our 10 will go here. So that's a picture for this one. So negative 2, then our 10 here. Then for the minor diagonal, you just have to change the signs. You don't change the position. So our positive 11 here becomes negative 11. Then this becomes positive 2. So our K inverse is equal to 1 over the determinant is positive 2. Then our adjoint is negative 2 to negative 11, positive 10. So this is our answer. Okay, so now we move on to question B. So under question B, we have a quadratic equation. Then we want to solve it. So we are finding the values of z, and we are going to give our answers correct to 2 decimal places. So let's look at the equation. So the equation is 3z squared is equal to 7z minus 1. Now, before you solve any quadratic equation, first it has to be in standard form. So the standard form is ax squared plus bx plus c is equal to 0. So the point is, first one, you begin with the one with the squared. So we have our 3z squared. Then this negative z will shift to this side. Then this will give us negative 7z. Then our 1 will shift also to this side, giving us plus 1 is equal to 0. So after we've removed this to this side, then the remaining part here is 0. So we have our A, B, and C. Then we can apply the formula. So we know that the formula for the quadratic equation is x is equal to minus b, but instead of using x, we use z, since we are solving the variable used was z. So z is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So the a is the coefficient of z squared, which is 3. Then our b is this number, -7. Our c is this number, +1. So we have z is equal to minus, our b is -7, plus or minus, so -7 squared. Our a is 3, our c is 1, over 2 times 3. So negative times this negative is 7. Then is -7 squared will give us +49, minus 4 times 3 is 12 times 1, we still have 12, over 2 times 3 we get 6 here. So z is equal to 7 plus or minus, so 49 minus 12 give us 37 over 6. So we can now find the square root of 37. So I'm getting about 6.08276253 over 6. Then we need to form two equations. One will have a plus, the other one a minus. So 7 plus 6.082763 over 6. The other one will have z is equal to 7 minus 6.08276253 divided by 6. So 7 plus 6.082763 will give us 13.08276253 over 6. So if we divide by 6, I'm getting 2.180460422. Now the final answer, we are told to give our answer correct to 2 decimal places. So these 2 decimal places, we have 1 up to 8, so it is 2.180. So this is same as the 3 significant figures. So let's do the other one. So 7 minus 6.08276253. So I'm getting 0.91723747 over 6. So we divide by now 6. So I'm getting 0.152872911. In our final answer, we only need 2 numbers after the decimal place. So we have 0.15 here. Since this number is less than 5, so we can't round it off. So these are the 2 solutions for this question. We move on to question 2a. Simplify m squared minus 1 over m squared minus m. So let us factorize the upper part. So we have m squared minus 1 can be written as 1 squared, since we know that 1 times 1 we still have 1, over. Now the denominator can be factorized by finding the common factor. So the common factor here is m. So m is common, we open bracket, m into m squared is just m, minus m into m, we have 1 here. Now these 2 will be factorized by difference of 2 squares. So we are going to open 2 brackets. So the one m will be written, the other one here. Then one bracket must have a positive, the other one a minus, 1 here and 1 here. So we can see that these two are common, so we can cancel them. So our final answer is m plus 1 over m. So this is our final answer. Do not cancel this because the m plus 1 is one expression, so these two are not the same. Okay, so now we move on to question B. The first three terms of a geometric progression are 6 plus n, 10 plus n, and 15 plus n. So our first term is 6 plus n is our first term. 10 plus n is our second term. 15 plus n is our third term. So for us to find the value of n, we know that the common ratio can be calculated as second term over first term, also is equal to third term over second term. So we are going to use this formula here. So we'll say second term over first term is equal to third term divided by second term. So our second term is 10 plus n over first term is 6 plus n is equal to third term is this one, 15 plus n over second term is this one, 10 plus n. Then we are going to cross multiply. So 6 plus n will multiply with 15 plus n. Then 10 plus n will multiply with 10 plus n. So let's use algebra. Now 15 times 6 is 90, plus number 2, 6 times n will have 6n. Then we move on to n times 15, we have 15n, plus n times n, we have n squared. Now we can now look at the other pair. So 10 times 10 is 100. Then 10 times n will have 10n. Then n times 10 will have 10n. Then n times n will have n squared. So what we are going to do here, we are going to collect every term with n on one side and every number without n on the other side. So let's add, these are like terms here, also here these are like terms. So say 90 plus 6n plus 15n will give us 21n plus n squared. Then you have 100. 10n plus 10n will have 20n plus n squared. Then so the 90 will move to this side, while the 20n and n squared will move to this side. So we are going to have 21n. This is positive 20, so it will change to negative 20n. Then we'll have this positive n squared minus n squared. This n will change to minus n squared. Then here we have 100 minus 90. Since here is positive 90, so after crossing it will change to negative 90. So 21n minus 20 will have just n. Then this will cancel, is equal to 100 minus 90 will give us 10. So this is our actual value of n. Now let's find the actual terms here. So the first is the second. So we know that the first term is 6 plus n, which is 6 plus 10 will give us 16. So here we'll have 16. The second term is 10 plus n, which is 10 plus 10 will give us 20. So our second term is 20. Then the other one is 15 plus any, which is 15 plus 10 will give us 25. So here we'll have 25. So these are the three actual first three terms. So let's look at now the Roman number 2 common ratio. So common ratio is second term over third term, sorry, over first term. So our second term is 20 over 16. So 20 divided by 16, I'm getting 1.25. Or if we want, we can also find the same common ratio, third term over second term. Our third term is 25 over 20. So if you divide 25 divided by 20, you still get the same value, which is 1.25. So this is how you can find the common ratio. Now we have the sum of the first 6 terms. So we are solving for the sum of a GP. So for the sum of the GP, the formula is sum is equal to, we have A, open brackets, since our common ratio is greater than 1, we are going to have r raised to the power n minus 1 over r minus 1. So that's the condition that you need to have in mind as long as you are dealing with the sum. Now let's do substitution. So where there's n, we put 6. A is our first term, 16. Then our common ratio is 1.25 raised to the power 6 minus 1 over 1.25 minus 1. Now let's do mathematics. So I have 1.25 raised to the power 6 raised to the power 6 minus 1. So on top I'm getting 2.81469726 over 1.25 minus 1 is just 0.25. So the same this one times 16. So I'm multiplying 16 times 2.8. So 2.81469726 times 16. So I'm getting yes, let me just get rid of this. I'm getting about 45.0351, okay, over 0.25 divided by 0.25. So I'm getting about 180. So this is the answer. So we move on to question 3a. In a box of 10 bulbs, 3 are fault. If 2 bulbs are drawn at random one after the other, find the probability that Roman number 1, both are good. Roman number 2, one is fault and the other is good. Now I personally prefer, even if the question is not asking you to draw a tree diagram, better you draw a tree diagram. That one will give us a visual representation of what we are talking about. So let's look at the information. So in this particular box, there were 10 bulbs. Now if 3 were fault, this means that 7 were good. So what you do is you subtract 10 minus 3, we have 7 were good. So since we only have 2 outcomes, our tree diagram we'll have two outcomes. So this is our first pick. So say F for fort, G for good. So since C2 were drawn, we need to have another second pick here. So this will be our second pick. So we have F, G, F, G. Now the first party here, you just have to write the number of, or the original probability for each outcome. So fort were 3, so this is 3 over the total 10. Now good were 7 over 10. Now here we are not told if these were picked without replacement or with replacement, but let's just consider they were picked without a replacement. Since if you pick a bulb from a box, you can't replace it back. So that is the assumption that we can draw from here. So if they were picked without a replacement, so we are going to assume that the bulb that was picked was fort without replacement. This means that 2 were remaining over 9. Since if we subtract 1 from 3 is 2, then from the total also must decrease by 1. Now this branch here, we assumed that fort was the one picked. If fort was the one picked, then the good, the ones that were good will still have the same 7 over the total 9 here. So the same total here must be equal to this. That is the pattern. Then for the other branch here, we are going to assume the opposite. So let's assume good was the one picked without replacement. So we are going to have 6 remaining over 9. Then here we know that we are going to have also over 9, but here we are going to have the same 3, since this time we assumed the good was the one picked. So from this part here, you can see the pattern. The total is always the same. We have 9, 9, 9, 9. So that is the point there. Now, so this will give us probability of picking 2 of the same that are fort. Then here we can see that we have F, G. So fort, good. Then GF. So here we have GF. Then the last one we have good, good. Now let's look at the first question. The first question is we want to find the probability that both are good. So here you just have to consider where we have the same letters GG. This is the answer that we are looking for. So probability of both good will be GG. So we use this number and this number because the two probabilities are representing good, good. So the first good is 7 over 10 times 6 over 9. So we know that 6 times 6 is 36 plus another 6, which is 42 over, here we have 90. So we can reduce 2 into 42 is 21 over 2 into 90 will give us 45. So 3 is still common. So 3 into 21 is 7 over 3 into 45 is 15. So this is our final answer. Now we have one is fort and the other is good. So here we need to find where we have different letters. So probability of 1 fort, then good also. So we are going to get FG plus GF. So FG is this one. So it's 3 over 10 times 7 over 9 plus GF is this one. So we have 7 over 10 times 3 over 9. So 3 times 7 we get 21 over 90 plus another 21 over 90. So we can add this, will give us 42 over 90. So if we reduce 2 here is 21 over 45, which is the same as 7 over 45. So this is how we can answer these questions. We move on to question B. The Venn diagram below shows tourist attractions visited by students in a certain week. So we can see that we have 2 tourist attractions, Victoria Falls, Mambirima Falls, and Gonya Falls. Okay. Now let's look at the first question. Find the value of y if 7 students visited Mambirima Falls only. So there is this condition of only. So let's look at which region indicates Mambirima Falls only. So this is Mambirima Falls only, because we can see that it's not intersecting any of the other 2 sets. Now, so this number indicates the Mambirima Falls only. So say 2y plus 1 is equal to 7. So from here we can collect the like term. So this positive 1 will shift to this side, giving us 2y is equal to 7 minus 1, which is 2y is equal to 6. So if we divide by 2, also by 2, we can see that y is equal to 3. So this means that where there is y, we have 3. So now let's get rid of this, so that we can now write the actual number. So this means that here we have 7. Now let's move on to Roman number 2. How many students visited Victoria Falls but not Gonya Falls? So we want everything that is in Victoria Falls but not intersecting the Gonya Falls. So let's do this. Let's first remove this. So if we remove Gonya, the only 2 numbers remaining are 6 and 2. And 6 and 2, they are part of Victoria Falls, so that is our answer there. So here we'll just say 6 plus 2 is equal to 8. This, not 8, but 6 plus 2 is equal to 8. Why? Because the 4 cannot be the answer, because it's part of Gonya. 10 is also part of Gonya, though it is part of Victoria Falls. Now let's move on to question B. 2 tourist attractions only. So we want the 2 attractions only is this region, this region, this region, except the intersection of all the 3 sets. So our answer will be 4 plus 2 plus 1. So 4 plus 2 is 6 plus 1, 7. Then for question C, 1 tourist attraction only. So 6 indicates that they visited Victoria Falls only, 7 Mambirima Falls only, 8 Gonya Falls only. So we need these numbers, 8 plus 7 plus 6. 8 plus 7 is 15, plus 6 we get 21. So this is how we can answer this question. We move on to question 4a. Express 3 over 5x minus 2 minus 2 over x plus 3 as a single fraction in its simplest form. So we have 2 fractions, these 2. So we want to combine the 2 fractions in order to form one fraction. So the first step is we need to find the lowest common denominator, for these two denominators. So the lowest common denominator, we just have to enclose those two in brackets. Then we are going to divide. So 5x minus 2 into 5x minus 2x plus x. So this means this and this will cancel, giving us 3 times this. That's why we just say 3 will multiply with x plus 3 minus, then x plus 3 into 5x minus 2x plus 3. This will cancel, giving us 2 and this one. So we're going to have 2 5x minus 2. That's why the simplest way is we know that this will multiply with this one, then this will multiply with this one. Then let's now expand. So 3 will multiply with x, will give us 3x. Then 3 with 3 will give us 9 here. Then we move on to this part, negative 2 times 5x, we get negative 10x. Negative 2 with negative 2, we get positive 4 over 5x minus 2 in brackets, x plus 3 also in brackets. So let's correct the like terms. So we have 3x minus 10x plus 9 plus 4 over 5x minus 2 in brackets, x plus 3 in brackets. So 3x minus 10x will give us negative 7x plus 9 plus 4 will give us 13 over 5x minus 2 x plus 3. So this is the simplest far that we can go. So now we move on to question B. So this is integration, part of calculus, because of this elongated s here. So we are going to integrate. So for us to find the integral, we are going to add 1 to the power given. So 3x squared will become 3x to the power 2 plus 1 over the same thing, over 2 plus 1 plus, so here we have the constant. So the constant, you just add x, becomes 2x. So whatever constant that you have becomes that constant times x. If it's 10, 10x, 5, 5x, so that's a pattern. Then evaluating from 5 to 2. So let's simplify here. We can see that we have 3x to the power 3 over 3 plus 2x, evaluating from 5 to 2. So you can cancel this. We know that we have now x raised to the power 3 plus 2x, evaluating from 5 to 2. After we are done integrating, we can now write two brackets. So the first bracket will have x raised to the power 3 plus 2x, but raised to the power 5 minus x raised to the power 3 plus 2x to the power 2. So let's look at here. We are going to have 5 raised to the power 3 plus 2, 5 here, minus 2 raised to the power 3 plus c. So where there is x, you substitute with 5 with the first bracket. Then here you substitute with 2. So 5 raised to the power 3 is 125. 2 times 5 is 10. 2 raised to the power 3 is 2 times 2 times 2, that is 8, plus 4. So 125 plus 10 will give us 135 minus 8 plus 4, we get 12. So 135 minus 12, we get 123. So 123 units squared, because whenever you have these intervals here, indicates the area that we were calculating. Move on to question 6a. In the diagram below, OABC is a parallelogram in which OA is equal to vector A and AB is equal to B. OB and AC intersect at D. E is the midpoint of CD. So under this polygon, which is a parallelogram, two opposite sides are equal. So this side here, this one, and this, so these two are equal. So this means that even here we have vector B. This side is also equal to this side under parallelogram, so also is here vector A. Now let's look at the first question. So the first question is we want to find the vector OB. So we can move in this direction or we can move in this direction. The answer will be the same. So we can say OA plus AB. So OA, we can see it's vector A plus AB is vector 2B. If we use this, will be 2B plus A, which is same as A plus B. Now we have this vector OB, we have it. Now the other question here, we want to find the vector OE. So from O to E. So how can we find this vector? So we are first going to find the vector AC. So for us to find the AC, we can use this root, or if we want, we can use this root here. So let's first find the vector AC. So AC is equal to, we are going to have AO plus C or C. Now vector OA is A. What of AO? So we are moving against the arrow, so this will be negative A plus C, or C is just vector 2B, which is we have 2B minus C A. So this is our vector AC. We have the O vector for AC. Now for us to move from O to E, we'll move from O to A, then A to E. So we are going to say OA plus C A E. Now let's look at we are told OB and AC intersect at D. Then E is the midpoint of CD. So this E is the midpoint of CD. This means that the letter E is cutting CD into two equal parts. So here we have 1, also here we have 1. That's what we are going to do. So if this distance is this one, even this one will also have this distance, and these two are equal. That is one property you need to know about a parallelogram. So we can also cut this into two equal. So we have 1, 1. So what this means is we are going to take it as a ratio. So this is 1 plus 1 plus 1. So from the vector AC, we want 3 quarters of it. So let's now show this by working. So vector OA is A plus C. So AE is 3 over 4. Where is this 4 coming from? We have 1, 2, 3, 4. Now from the 4, we only want 1, 2, 3. That's why we have 3 over 4. Then of vector AC. The vector AC is 2B minus A. So let's see how we can simplify it. So 3 times 2 will give us 8B. I mean, not 80. This should be 6B. So 3 times 2 will give us 6. b over 4. Then 3 over 4 times the negative a will give us 3 over 4 of vector a. Then we can collect the like term. So first let me get rid of this. We are done using it. So we now collect the like terms. So the like terms, we have vector a minus 3 over 4 of this. So say over 1. Then plus 6 and 4 we can reduce this. 2 into 6 is 3 over 2. So let's look for common denominator for these two numbers. So we are trying to combine a with negative 3 over 4 of a. So the lowest common denominator is 4. So 1 into 4 will give us 4 times a. We have 4a minus 4 into 4 is 1 times 3a will give us 3a plus 3 over 2 of vector b. So 4a minus 3a will give us 1 over 4 of vector a plus 3 over 2 of vector b. So this is our answer. Now let's look at CD. So CD. So we know that we have the vector for AC. Now, since we have these 4 ratios here, we can see that from C up to E is 1, E up to D is another one. So this is 2, which is half. So this is the same as 2 over the total 4. So from the vector CA, we only need half of it, which is same as 2 over 4 is same as 1 over 2 if we reduce this one. Then it's 2 over 4 of vector CA. Now remember, vector AC gave us 2b minus A. So what is this? This was vector AC. So now what is CA? So CA is like we are changing the direction. So you just change the sign of these two vectors. So we are going to have negative 2b plus A. So it's 2 over 4 of vector negative 2b plus A. So if we expand, we know that 2 times 2 will give us negative 4b over 4 plus 2 times A will give us 2a over 4. So 4 into 4 is negative b. Then here we can reduce is half a, which is our answer here. Now we can move on to the last question for this lesson. The program below is given in the form of a flowchart. So we have start, enter, a error is absolute error less than 1. If yes, then you calculate sum to infinity. Then you display sum to infinity. Then if no, you just stop. So how do we write a pseudocode? So the pseudocode is just it consists of statements that are readable. Then we'll say you start. So we have start here. You say start. Then from there we have enter a and error. So a and error, these are inputs. So we say enter a comma error. Then here we have a question is, but under pseudocode we need to write if absolute error less than 0, less than 1, then indicates yes. So for the question where here, if we say no, there is no display here, so we first consider this part where we have something to do. So we consider yes. So the yes goes with then we'll say calculate. So we'll say calculate. We have been given the formula sum to infinity is equal to A over 1 minus R. Then what are we going to do? Display sum to infinity. So we are done with yes or else. Or else indicates that if we say no, or else. So or else means if we say no. If we say no, we can see that we are supposed to stop. So this is how we can write a pseudocode for a program like this one. And that's it for this video. Thanks for watching.